Welcome back after the break. Now, just before the break, we discussed berg winds. They're like the name indicates, like mountain winds. Now, I just want to go back to 1.3.2 to explain this process. It's a high pressure system over the interior of southern Africa. Air moves from a high pressure to a low pressure, so it moves down the escarpment into the coastal low pressure, creating berg winds. Now, the reason why we only experience it in the winter is because of the strong presence of the Kalahari high pressure. There's a very strong subsidence taking place in the winter because of cooler temperatures as well. Now, our next question is the paragraph question. In a paragraph for approximately 8 lines, explain why berg winds are regarded as a threat to the farming communities, especially along the east coast of South Africa. Now, keep in mind, people don't like berg winds, and we're going to have a look why it's a threat to the farming communities. Now, please remember, this is a paragraph question. You need to answer this in paragraph format. I'm going to write the correct answers, the facts, in bullet formation. But please do not do this during your final exam. So let's continue. The reason why was berg winds is regarded as a threat. The first reason, it creates very hot and dry conditions. It's very hot and dry conditions and can be a fire hazard. Another reason we don't actually like the presence of it, because if a fire does develop, it can lead to the crops being destroyed. Livestock can be burned to death. Destruction of grazing land. Now, obviously, they need a grazing land for their stock, like for cattle and that, and sheep. And obviously, because of the fires that's being created by the berg winds, it can lead, now the less products is going to be produced, and especially now we're just talking about commercial farmers. Subsistence farmers who farm for themselves will be left without no food. So not only the commercial farmers will suffer their loss of their livestock and damage of crops, and it means they're going to earn less profits, but subsistence farmers won't in the area, will have no food. And lastly, another reason we can go and have a look at, it can cause a loss of income. Because of these fires, it can create devastation. It means the crop that's been burned provides the farmer with income. He won't be able to pay his workers. It might lead to unemployment, and eventually it can lead to rural-urban migration as well, because there's no point continuing the farming because the farmer doesn't have money to continue farming his crops. So that's the reason berg winds are regarded as a threat in South Africa. Now I quickly want to look at our next question, question 1.4. And if you look at question 1.4, we're discussing mid-latitude cyclones. Now when we look at mid-latitude cyclones, like the name indicated, it's a low pressure system, it's a low pressure. Mid-latitudes, where they originate from, and we know that mid-latitude cyclones plays a vital role in the rainfall for the Western Cape, especially during winter, because what happens, our South Atlantic high pressure system migrates north, and that means these cold fronts can bring much needed rain to the Western Cape area. As you can see, very easy to identify, mid-latitude cyclones consist of a cold front, and attached to the cold front is the warm front. Now I'm just going to fill my information over here because that's what we've learned during our theory bit. Now, as you can see, the cold front is the leading edge of the cold air. Between the cold front and the warm front is the warm air, and in front of the warm front is the cold air as well. We know it's a cyclone in the southern hemisphere because look at the clockwise circulation. And what do we know about this whole system? That it migrates from west to east. And as you can see, the pressure is well below 1,000 hectopascal. And let's go and look at some of the questions that they asked regarding this mid-latitude cyclone. What evidence in the diagram shows that Cape Town is experiencing winter? Now, first of all, there's no temperature to be able to tell us, but the reason we know it's winter is because Cape Town is getting affected by this cold front. And when do we usually see Cape Town being affected by cold front? During winter months. So the cold front, the presence of the cold front, and we can say the mid-latitude cyclone is present. Okay, now our next question, does front X or front Y have the greater effect on the weather of Cape Town? Now let's just quickly have a look when they refer to front X and Y. Now front X is the cold front and front Y is the warm front. We in South Africa do not experience the warm front, but only the cold front conditions because the warm front is too far down south to have any influence on South Africa's climate. Now, before we're going to look at the next, before we answer the question, what basically happens over here? I've explained it to you before. That cold front tries to catch up with the warm front. And while it's doing it, what does it do with the warm air that we find in this area over here? Upliftment of warm air. So it cool, condense clouds and formation of rain. But let's go back to our question. And the question stated, does front X or front Y have a greater effect on the weather system, weather in South Africa? And that's definitely X. Now 1.4.3, the Weather Service forecast severe weather conditions for Cape Town. Two of these expected weather conditions are, what do you think is going to happen? Now first of all, when we move back, I'm quickly going to draw a cross section through this mid-latitude cyclone. Now we've learned this is basically the mature stage. There's the warm front that represents over there, and let's just make this in yellow. There's the cold, oops, let me just wipe this out. There's a cold front representing the blue lines over there. So what happens? The cold air is approaching. Okay. So as the cold air approaches, what do we know? It's much denser, it's heavier. So what does it do with the warm air? The warm air that we find in this area over here. It forces the warm air up to rise. It cool, condense, clouds, and rain. Now look at the pressure gradient over there. It's quite steep. So this air is forced to rise, not gently. So we're going to experience cumulonimbus clouds over there. So let's quickly look at the question over there. The Weather Service forecasts say two of these we can expect. We're definitely going to expect heavy rainfall, thunderstorms, okay, we're going to experience low temperatures, closer to escarpment, very good chance for snowfall to be experienced, hail as well, and gale force winds. Very strong winds that we might expect over there. Now, if you look at question 1.4, explain how the severe weather conditions will affect the people living in informal settlements. Now, Gr12, what's the informal settlement? An informal settlement, remember, is not rural areas. The informal settlement is usually on the outskirts of our urban areas. The reason why informal settlements develop is because of rural-urban migration. People go and look for better job opportunities, better services. But the problem is an informal settlement develops because there's not enough housing for the people. So an informal settlement lacks proper infrastructure, like sanitation, like sewage, like electricity, and like proper housing. So how do you think that these severe weather conditions, like we just discussed, I mean, very high rainfall over a period of days, they might even experience some snowfall, hail, and gale force winds. Now keep in mind, if you look at informal settlements, what do they use to construct their homes with? Usually with iron, wood, and sheet metals. That's not very, very strong to be able to protect them against very strong winds. So what can we say over there? Explain how the severe weather conditions will affect the people living in informal settlements. Now, obviously, when it rains a lot, flooding will destroy their houses. We can also say strong winds will blow away the shacks. Okay, people might fall ill. And we can also say there's going to be a lack of clean drinking water. And it can lead to waterborne diseases such as cholera, because what can happen, the sewage can infect the water and can create water pollution. So it can be a great concern. Another reason that we can mention, it can create more people to lose their house. That can lead to people being more homeless as well, and it can create more pollution because there's no decent infrastructure around informal settlements. Now, if you look at question 1.4.5, explain why there will be a difference in the weather experience at Cape Town and at Mossel Bay. Now, if we quickly go back to our diagram, we will see the following. There's Cape Town and there's Mossel Bay. Now, if we look at the isobars are much closer to the area in Cape Town than in Mossel Bay. And what we've learned in this situation over there, if the isobars are close to one another, we say the pressure gradient is much stronger and the winds are going to be faster and more gale force winds. If the isobars are quite far from one another, it's more gentle winds. But let's have a look. So what's going to be the difference in the weather being experienced? Now let's quickly go and write our answer down on the next page. Now, Cape Town will experience more severe weather because the cold front is right next to it. More severe weather because close to the cold front. And we can also say that Mossel Bay will experience less severe conditions because it's closer, further away from it. Okay, Mossel Bay further away. You can mention that as well from the cold front. Okay, and a last point that we can mention, the isobaric pressure. Okay, isobaric pressure is less at Mossel Bay than in Cape Town. So that's the reason Cape Town will experience worse conditions or stronger winds, more rainfall and more severe weather than Mossel Bay. Please stay tuned and we'll continue directly after the break.